Good morning, good afternoon, good evening. Whenever you are watching this video, let me welcome you all to our channel Future Endeavors. Okay, so without wasting much time, we will be quickly moving on to our topic. We have been discussing about refraction through lens, and in the previous two classes we have discussed quite a thing about lens, various types of lens, some technical terms related to lens, and we have also discussed how light ray behaves in certain conditions or certain cases while passing through concave or convex lens. Okay, and we have also discussed about real and virtual image. So today we will be specifically discussing about the ray diagram. Now, what is actually ray diagram? It is nothing but determination of the position and nature of the image depending on the position of the object with respect to the lens. Okay, so we will be discussing about convex lens. So we can consider the heading as ray diagrams of convex lens. Ray diagrams of convex lens. Okay, fine. So let us talk about the various ray diagrams of convex lens. Sorry. So first of all, I think you have watched the previous video and remember that we require at least two rays in order to determine the position and nature of the image. Okay, so considering those two rays, I have discussed which two rays we can take while drawing the ray diagrams. Okay, now first of all, let us consider convex lens. Okay, so first we will be considering that for the first diagrams that we are drawing are all related to convex lens. So first we will be considering that the object in the first case is at infinite distance. Okay, so first figure we will be drawing is object is at infinite distance. So object at infinity. So this is the first case. Fine. So let us see how or where the image is formed while the object is at infinity. Now, first of all, just let us draw the convex lens, something like this. I consider the convex lens. Okay, so this is the central axis and this is the principal axis. Okay, fine, and this is our optical center O. So when the object is at infinite distance and we are considering that the light rays are coming parallel to the principal axis, what happens then? So light rays are coming parallel to the principal axis. Okay, just first of all let me point out the focal points. So what are the focal points? Say this is F1, this is F2, and here you can consider it as 2F1 and this as 2F2. Now why we are considering 2F1 and 2F2? Question must be coming to your mind that there are two focal points marked by points F1 and F2, that's enough. So why I am taking 2F1 and 2F2? So basically you have remembered one relation when you have read in class 9 about mirror, that focal length is half of the radius of curvature. So in case of lens, we have studied that there are two center of curvatures and there are two radius of curvature. So basically this 2F1 and 2F2 represents the two center of curvature of both the lens surfaces. Okay, as we are considering a biconvex lens, obviously it is made from two spheres, so there will be two center of curvatures. Those are noted as 2F1 and 2F2. Why this is 2F1? Because here the F1, 2F1 represents the center of curvature, as because we know the radius of curvature is twice the focal length, so it's 2F1. Okay, fine. Now when the light rays are coming parallel to the principal axis, so say light rays are coming like this, one ray, we can consider at the most we need to consider at least two rays for drawing the ray diagram. So these are the two rays that I have taken coming parallel to the principal axis. So we know that what happens when the rays come parallel to the principal axis? You must remember that when rays come parallel to the principal axis, they tend to pass to the focus. So what will happen? This will pass like this and this will pass like this. Okay, so please, I apologize for not the exactness. I have not drawn the figures exactly. Slight little bit of it will be passing to exactly this F2 point. Okay, so this is rather the point is exactly on the F2. Okay, so here the image is formed. Okay, so when the object is in infinite, what happens? The image formed is at F2. So first of all, what is the position of the image? Position of the image is at F2. The image is real. Obviously, then if it is real, it is inverted. You know, real images are always inverted, as we have studied in the previous class. Okay, and third point is that the size of the image is diminished to a point. So third point is diminished to a point. Diminished to a point. So remember these three characteristics of the image form. Sometimes they are being asked in the question in the examinations. Okay, fine. So this is the diagram. So I think the diagram is clear. Okay, I will be separately giving you some points how to draw these ray diagrams exactly. I will be talking about the later on. First, let us just go through the diagrams roughly. Okay, fine. So this is the diagram. I think it is clear. Now coming to the second diagram. Okay, so I am just rubbing it off. Okay, I will not rub the entire diagram. I will just erasing of the rays, light rays, because with the change in the position of the object, what happens? The light rays will be changing the directions a little bit. Okay, and I am also okay, I am also removing these three characteristics. Okay, and I will be changing the heading. Okay, so you will have to draw the diagram once again. You have to do a little bit of hard work here to draw the diagrams again and again. Okay, so it's clear. Now the second case is that the object is just beyond F2, sorry, not F2, just beyond 2F1. Okay, means the object is just behind the center of curvature. Okay, fine. Now what happens here? If I consider the object just behind the center of curvature, so I can consider the object to be somewhere here. So this is the object denoted by the letter say AB. Okay, I think the figure is clear. Yes, it is okay. So we are considering two rays. Let us consider one ray parallel to the principal axis, coming parallel to the principal axis. So after coming parallel to the principal axis, the ray is passed through the focus. Okay, it's passed to the focus. Fine, passed the focus. Let us consider another ray. We will consider another ray passing to the optical center. So you know that when we are all discussing about these points about thin lenses. So for thin lens, ray passing to the optical center passes undeviated. So it will be just going undeviated. Okay, fine. So if I consider the light will be passing undeviated, so how it will be coming? Okay, can you guess why the image will be formed? Let us see. Okay, so can you guess the image? Why the image will be formed? See, here if you consider the light will be passing to the optical center, so it goes somewhat like this. Okay, it goes somewhat like this. Okay, I am not being able to draw the exact diagram because of the I am not having a scale, so it will be something like this. Okay, now the image will be formed here. So you can actually see what happens here. What happens? Okay, so what happens here? The light ray is slightly bent. Okay, just let me rectify it a little. It will be a little bit more upward. Okay, so it will be passing like this, okay, and like this. Okay, fine. Okay, so if I consider actually the diagram, so the image is, when the object is just beyond 2f1, the image is found between f2 and 2f2. So first of all, first point is that image is found between f2 and 2f2. First of all, second point is obviously it is real and inverted. Okay, and third point, it is not diminished to a point but rather diminished. The size is less than the size of the object. Okay, so it's diminished. Fine. So these are the 3 points. Okay, I am not able to draw the diagram exact, so the size is not coming exact, but the image will be diminished a little bit. Okay, fine. So this is the second case. Third case, now considering over third case, the object will be coming at 2f1. So okay, another thing, mark this image as a dashed and b dashed here. Okay, so please note it here that the image should be written as a dashed and b dashed. Okay, fine. Now moving on to the next case where the image will be object will be coming onto the point at 2f1. Okay, f1. Okay, 2f1. Fine. Now when the object comes at 2f1, let me just rub it here also. So the object comes at 2f1. Fine. So if the third point is that object is at 2f1, exactly 2f1. So what happens here? Here, if I consider the object at this point 2f1, let's say the object is AB, it will move out like this. After passing to the focus, it will move out like this. Okay, and it will have to extend it a little bit here like this. Okay, and the image will be found exactly at 2f2. So it will be something like this and this. Okay, so the second ray taken is to the optical center, it will pass undeviated and the image will be found at exactly 2f2. Okay, fine. So what about the position of the object? First of all, the position of the object is at 2f2. Second point is that it is obviously real and inverted, nothing new about that. And third point is the image is of the same size as object. So here is the change. In the previous two cases, the image was diminished. The image was being diminished. Okay, but here the image is of the same size as that of the object. Okay, so image should be written as a dashed and b dashed. Fine. Okay. So I think that the concept is clear. Okay, now quickly moving on to the fourth diagram. So fourth diagram we will be considering where the image is between 2f1 and f1. So the object is coming closer to the lens. Okay, you must be seeing if you follow the diagrams, the object is slowly coming near to the lens, and what happens as a result, the image is getting a little bit shifted away from the lens. I think you have noticed this change, isn't it? You have noticed this change. as the object slowly moves towards the lens, the image is slowly shifting away from the lens. Okay. So just let me redraw the basic figures. So it's 2f2 and this is the optical symbol. Fine. Now the fifth point that comes is the object is between 2f1 and f1. Okay, so when the position of the object is such that it is between 2f1 and f1, a b is the name given to the object. So first of all the ray comes like this. Okay, then it passes to the focus. Okay, just let me extend this a little bit more. I think figure is clear. Okay, another ray passes through the, it will sound like here. Another ray passes the optical center like this. Okay, and it will go just beyond. Okay, so you can see that the ray is meeting at a point like this, and if I consider this position, this is beyond 2f2, isn't it? Beyond 2f2. The image once again is real, inverted, but the size has been what? Increased, magnified. So characteristics of image is found beyond 2f2. It is obviously real and inverted. Okay, and third point is that it is magnified. It is magnified. Fine. So this is the fifth diagram. Okay, fine. Now coming to the sixth diagram. Okay, so sixth diagram will be object. Object will be at exactly f1. Okay, so it is an interesting case. Object, if it comes exactly at f1, then what happens? Let us just see. Okay, so when the object is at f1, so what happens? Let us see. f1. This is f2 as usual. F2. Okay. So when the object is at f1, so here the sixth diagram is object at f1. Object at f1. Okay. Sixth is object at f1. So when the object is at f1, what happens? The image is further shifted. How it is shifted? Let us see. Consider the object at f1. Okay. So here the one ray will be taken like this, where the principal axis. After refraction it will pass through the focal point, and another ray will be passing like this to the optical center undeviated, through the optical center undeviated. Okay. So see here, in this case, the two rays that are emerging out, they are emerging parallel. So can you say that where the parallel rays will meet? No, you cannot say. So I can say that the parallel rays will meet at infinity. So here actually there is an interesting case. When the object is at f1, the image is formed at infinity. So you see, when the object was at infinity, image was formed at f2. Now object is at f1, the image is formed at infinity. So it's interesting case. Second is obviously it's real and inverted. Obviously it's real and inverted. There is no doubt in that. And the third point is The image is highly magnified. Remember this point. Highly magnified. Okay, not only magnified but rather highly magnified. Okay. So this is the characteristic of the when the object is at f1. Fine. Okay. Now again let us consider the last case, the seventh case, when the object will be between the optical center and f1. Okay, the object will be in between the optical center and f1. Again, this is a interesting case as it will lead to a bit different result. Okay, so what result are you waiting for? Let us see. So what happens here is okay, so the object is between f1 and optical center. Okay, optical center. So this is the seventh diagram that will be considered. Fine. So when the object is at f1, what happens? When the object is at f1, so here the object is like this, AB. The ray will be diverted like this. Okay, another ray will be diverted like this. Okay, it will be tilted a bit. Now you see, if I consider the two rays, they are actually getting diverted like this. So if I just trace it back, okay, if I just trace it back, okay, I am drawing the figure a little bit, okay, like this. It will trace it back. Then these two rays will meet at a certain point, and here what happens? The object will form a virtual image. Okay, so the object will form a virtual image. Okay, so this is the case where a convex lens forms a virtual image. So position of the image is behind, sorry, not behind, in front of lens. First of all the previous cases where the image was formed behind the lens. Second is that the object, the image is virtual and erect. Okay, and third case is magnified. Now I am just giving one information here that this kind of diagram is actually for a magnifying glass. You all have seen magnifying glasses. Now you see for a sorry, I have just drawn the diagram a little bit wrong. The object must be at between f1 and f1. Sorry for that. Just correct it a bit little. Okay. So just no need to change the nature. Just change the position of the object. I have not changed it. Sorry for the inconvenience that I caused. Okay. So if I consider the object, so this is the optical center. This is the optical center O. Okay. So if I consider the object to be drawn here, placed at here, what happens? One light ray is just going like this. Okay. Another light ray is just passing like. Okay. So they are, you can see actually they are being diverted in such a way that if they are traced back, they will meet at a certain point behind the lens. Okay. So this will be the figure. I am very sorry for the inconvenience. Please. I apologize for the mistake done. Okay, so this will be the figure. Now, very important to put the arrows in a ray diagram. I have said again and again, without putting the arrows, it will be totally wrong. So please put the arrows in the ray diagrams. Okay. So this is the figure. So these are the 7 cases. Okay, we have talked about today. So we will be ending our lecture here. Please practice the ray diagrams. In the next class, we will be discussing about the ray diagrams of the concave lens, and we will be telling how to draw the diagrams exactly in your copy. So till then, please do study well, and if you have any comment, any query, please mention in the comment section. We will be happy to solve your problems. Till then, goodbye. Thank you.